All right, well, today we are going to be talking about electron configuration. All right, so let's talk about exactly what we mean. So you might hear us talk about electron structure or electron configuration. This is really important for figuring out the properties of the elements. It actually helps us to be able to predict how these elements are going to behave, how they're going to bond, how they're going to react. And really what this is going to focus on is the location of the electrons. So at this point, we've talked about the nucleus of the atom. So we know that the protons and neutrons are in the nucleus. And we've talked about the fact that those electrons are somewhere outside of the nucleus. And this is where we're going to focus on I won't say exactly where those electrons are, but kind of our general idea of where those electrons might be. All right, so just a couple of definitions that we need to kind of run through. Really, there are two. The first would be what we're going to call energy shells or energy levels. There are 7 total, and there is 1 per period. So essentially what we're going to be doing here is using the periodic table to help us figure out where those electrons are, what that electron structure looks like. There is a lot of information behind this. So if you've taken chemistry before, you may have gone into this in a little bit more detail. We're not going to do that in this course. We're going to give you basically exactly what you need. So the first thing is energy shells and levels. There are 7. We have 7 periods. There are 7 energy levels. The second definition, we are going to be talking about subshells. I tend to call those orbitals. And in each energy level, you are going to find a subcategory of subshell or an orbital, and there are 4. There are s orbitals, those can hold up to 2 electrons, p orbitals, which hold up to 6, d's, which hold up to 10, and f, which holds up to 14 electrons. Now, what we're going to be doing is taking those 2 definitions, so our energy levels and our orbitals, and putting this on our periodic table so that we can use that to help us figure out what the electron structure looks like. First, like we talked about, our energy levels, we have a total of 7 periods, and so that's going to correlate to our 7 energy levels. So 1, 2, 3, 4, 5, 6, 7. So everything in the first period, those electrons are going to exist in that first energy level. Everything in the second period, those outer electrons are going to exist in the second energy level. Now we're going to take our orbitals or our subshells and put those into our periodic table. Now this is kind of nice. It's done this kind of for us. And one thing I want to notice that helium's over here. I'm actually going to go ahead and draw helium over here for myself. Because really helium is going to electronically behave as though it sits in that, kind of sits in that column. And we'll talk about that in a little bit later. In our first energy level, or in this particular block here, I don't really want to highlight these, but everything here in blue, so hydrogen down to francium, helium down to radium, those are going to be our S block. This is our S block. Remember we said the S orbitals can hold up to 2 electrons. We have 2 blocks. So an electron and an electron. So if I completely filled up the S block, I would have 2 electrons, 2 blocks in that particular spot. The area shaded in green, those are our P, that's our P block. So that would be these guys here. And remember we talked about the fact that P's hold up to 6 electrons, and if I count across, I've got 1, 2, 3, 4, 5, 6 blocks in the P's. Completely filling up those P's would be 6 electrons. Now, before I start talking about the D's and the F's, I want you to notice that for each energy level, for each period, and for each block, I have this labeled. So underneath hydrogen, I have that labeled as 1s. That's letting me know that the electron is in the first energy level and it's in an s orbital. It's in the s block. Hydrogen only has one electron, and so that one electron is going to sit in the 1s orbital. And then we're going to denote the fact that hydrogen only has one electron with a superscript. So this guy right here. So letting everyone know there's only one electron for hydrogen, and the electron configuration for hydrogen would be 1s1. And we'll do some practice with this on the next slide. Energy level 1, everything is labeled with a 1. Period 2, which is energy level 2. Notice I have 2s and 2p. Again, letting everyone know those electrons are in the second energy level. 3 looks pretty normal, 3s, 3p. Things start to get a little bit weird when we start to talk about the D block. So our D block are these guys right here, our transition metals. And again, we said the Ds could hold up to 10 electrons, and if I count across, I have 10 spaces, so 10 electrons. But notice the Ds don't show up until we hit the 4th period. And then notice here that for the Ds, I've got a 3 in front of there for period 4. Now this is something, if you've taken chemistry before, you will have heard this. If you've not taken chemistry before, don't worry about it. The way the electrons are organized is they go from lowest energy to highest energy. And they're going to organize themselves that way. And it turns out that 4s is actually a lower energy than 3d. The thing you're going to have to remember is that the D blocks, they are going to be one energy level below the period you're in. So starting with energy level 4, period 4, as you go across, it's 4s, and then it's 3d, one energy level below. And then once we get to the P's, we're back up to the 4th energy level. Same thing happens in the 5th period. I go 5s, 4d, and then 5p. The last block are going to be the F block, and it's these guys down here, highlighted in purple. That's supposed to be a K. And again, we talked about the F block being able to, or the F's being able to hold 14 electrons. If I count those squares, I've got 14 of them. Notice that I have this red line right here. That literally, the periodic table is organized this way to fit on a piece of paper. If you notice, we go from 57 and then we jump up to 72, and 58 to 71 are actually down here. This is where the F block sits. So it really starts in period 6 or energy level 6. We're really not going to ask you about these, but I just want to point out that the F block are 2 energy levels below the period you're in. And again, they don't start until period 6. And like I said, things get a little bit funky and weird down here in the F block, so we're really not going to ask you about those, but just be aware that that exists and know how many electrons they can hold. I would pause the video at this point if you've not taken notes. Make sure that you have a workable periodic table that you can write on and draw on that you can use for studying purposes. When you take an exam or quiz, you will be using a clean periodic table that doesn't have all this information on it, but it's helpful when you're studying to have all of this so that you've got something to work from. All right. So I've got our small periodic table here. We've already done the electron configuration for hydrogen. Remember, hydrogen's right here. Hydrogen is in energy level number 1. Has 1 electron. That electron is going to sit in that first block of the S. And so that gives us 1s1. If we do helium next, and again, working with this, I really like visually having helium here. That's just the way this is organized. So helium is the second block of 1s. Helium has 2 electrons, so the electron configuration for helium is going to be 1s2. If I come on down here to lithium, and this is kind of silly, but I really like looking at this literally like it's a game board. And I always have to start at the top, have to start at hydrogen. Hydrogen's my go. So when I get to the second energy level, I have to completely fill up the first energy level first before I can go ahead and get myself to the second energy level. So lithium has 3 electrons. I'm going to put those first 2 electrons in 1s2, right? So I'm going to completely go across that 1s, and then I am 1 block into 2s. And so I have 1 electron in 2s. Let's do boron next. So boron is right here. And again, I want to start myself right at the beginning. Okay. So I want to start right with start with hydrogen, and I'm going to go across that first period. So I am filling up 1s2. I'm completely going across the S block for energy level 2 or period 2. So that's going to be 2s2. And then boron is 1 space into the P block, and so that is going to be 2p1. So carbon's going to follow just like we did with boron. I'm just 1 space over. So 1s2, 2s2, 2p2. Now, the last one I have here is a slight bit of a challenge. Notice, so iron is right here. I've got 26 electrons. All right, so I'm going to start with right? I'm going to start with hydrogen, go all the way across. So I have filled up 1s2. Now I'm going across that second energy level where I'm filling up the S block, and I am completely filling up that P block. Now I am coming down to the third energy level, and I'm going all the way through there. So I filled up 3s2 and 3p6. I am going down to the fourth energy level. I'm going completely through the S block. That is 4s. And now I am 1, 2, 3, 4, 5, 6 spaces into the D. And remember that the D's are 1 energy level below the period that you're in. So the complete configuration for iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. All right, so this is your practice. So you should take a couple of moments and see if you can get the electron configurations for sulfur, argon, and zinc. Now, you saw when we did iron, it was a lot of writing. Can you imagine if I asked you to do something like lead? 82 electrons, starting from hydrogen, working my way through to do the electron configuration. It's a lot of writing. Generally, we're not super concerned about the innermost electrons. We're really concerned about those outermost electrons. That's where all the chemistry happens. And so we're going to talk about a shorthand or noble gas configuration, number 1, so we don't have to write all of that out, but number 2, so that we can focus on the electrons that we're really interested in. So the first thing we're going to do is we are going to do the electron configuration for argon. So argon's right here. So I'm going to do the full longhand configuration for argon. So again, starting with hydrogen, go across that first energy level, so I'm 1s2 all the way across here. And then I'm going across 2s2 all the way. And now I'm in the P block in that second period, so it's 2p6. And then I am in the third period going through the S block, 3s2, and then all the way through the P's, and that takes me to 3p6. And there's a method to the madness here. I want to do the full long form of bromine. And again, starting with hydrogen, right, I'm going all the way through the S. Then I'm going down to the second period and I'm going through the S and I'm going all the way through the P block. And then I'm going through all the way through the third period, 3s2 and 3p6. And I really should have given myself more space. Let me rewrite this a little smaller. Sorry about that extra time. Okay. Okay, so I've gone all the way through the third period. And I'm now into the fourth period, going across 4s2, going all the way through the D's. And remember, the D's are one energy level below. And then I am 1, 2, 3, 4, 5 spaces into the P. So that's 4p5. That's a lot, right? That's a lot of writing. Now, what we're going to do for this shorthand is we're actually going to use what we're going to call the noble gas configuration. If you look here, argon is 1s2 all the way to 3p6. I have 1s2 to 3p6 right here. What I have highlighted in the bromine longhand configuration is the electron configuration for argon. Rather than writing out that whole thing, I am going to, for my shorthand, I am going to write argon in brackets, and then I am going to finish it up with my outermost electrons. So this right here is that 1s2, 2s2, 2p6, 3s2, 3p6 is represented by argon in brackets. And then I'm going to write out the rest of my electron configuration, which is 4s2, 3d10, 4p5. I'm actually going to do phosphorus with you. Now what I do for my shorthand configuration, because it's a lot to go through all of the steps that I just did. So if I want to do my shorthand configuration, I'm going to find my element that I'm doing that for on the periodic table. And then I'm going to back myself up and I'm going to look for the noble gas that ends the period before. And in this case, it would be neon. So if I write neon in brackets, I am essentially saying 1s2, 2s2, 2p6. And then I can focus my attention on the outside. So for my shorthand for phosphorus, I'm looking for the noble gas that ends the period before. In this case, that would be neon. And then I'm going to go ahead and fill in the rest. I am filling in 3, going across the S block, and I am 3 spaces into the P block. Definitely practice these. You'll definitely get some practice in class. It gets easier the more that you practice with it, but do make sure that as you're practicing, you sit down with that periodic table that you've drawn all over. You've got your P blocks and S blocks and D blocks all labeled for yourselves.